अपने लास्ट लेक्चर में हमने देखा था कंटिन्यूटी ऑफ ए फंक्शन है. सो वी विजुअलाइज इट द कंटिन्यूटी ऑफ ए फंक्शन एट ए पर्टिकुलर पॉइंट एंड कंटिन्यूटी ऑफ ए फंक्शन थ्रू आउट इट इज डोमेन. And we say a function f of x is continuous at a particular point. X is equal to a is any point within it is domain. Then when do we say the function is continuous within that point? When limit x approaches to a, f of x is equal to f of a. That means उस पॉइंट पे लिमिट ऑफ द फंक्शन दैट शुड बी इक्वल टू द वैल्यू ऑफ द फंक्शन. सो लिमिट x approaches to a, f of x has to be equal to f of a, which means the limit in the left hand side has to exist and that should be equal to the value of the function at that very point. And we say a function is continuous throughout its domain. ठीक है ओतामत ऐसे जो ना एक इस particular point इस पर आइस तम साथ continuous when limit at that very point so इसका बराबर f of x is equal to f of a. And when do we say a function is continuous throughout its domain? When it is continuous for every point within its domain. ठीक है ये domain के प्रत एक इस point खतर so function is continuous, then we say the function is continuous throughout its domain. ठीक है it is again the synonym word for continuous function. Continuous function means continuous throughout its domain. ठीक है अगर इस वनो एक function ची continuous then we mean it is continuous throughout its domain, which again means it is continuous for every point within it is domain. ठीक है so then I switch out continuity of a function must we choose then algebra of the continuous function. The sum of two continuous functions is also continuous. The product of two continuous functions is continuous. The difference of two continuous functions is continuous and quotient of two continuous functions is continuous function. Even अगर इस दोन continuous function and composition करो, the composition of two continuous functions is also continuous function. ठीक है and geometrically geometrically what do we mean by a continuous function? So a function which does not have breaks within its graph. ठीक है या अगर इस continuous function वुचो तथ function वनो इस continuous function यमिच graph त्रावा पेन वथना थूत किन. ठीक है so that is called a continuous function. ठीक है so but continuity was defined in terms of the limits. ठीक है so इथे पे अगर इसको differentiability of a function करो define, we also define the differentiability of a function by using limits. So as I told limits क्या है, it is the basic building block of calculus. Calculus में majorly यम चीज is define ची करन, those are defined in terms of limits. So already which is continuity of a function हमने देखा अगर limit x approaches to a, f of x is equal to f of a, then we say the function is continuous at a particular point. X is equal to a. So x is equal to a अगर कहाँ की point से within the domain of the function that point is पर किम साथ ऐसे continuous when limit x approaches to a, f of x is equal to f of a. ठीक है where a is any point within its domain. So ऐसे करे ये function करे is define यानी continuity of a function करे is define in terms of limits. ठीक है so again we will define the differentiability of a function at a particular point, but again we will use the concept of limits again here. So इस वनो suppose f of x and chase कांति function. So given a function f of x, ठीक है if we have to check whether this function is differentiable at a particular point or not. एक इस particular point इस पे अच्छा ये function differentiable केन ठीक है differentiable केन. Then we have to see at that very point suppose I say this is any function, say we have an association between the domain set and codomain set. ठीक है domain set तो भी codomain set इस दरमियान चाक map exist गसा matching exist गसा such that x is matched onto y. ठीक है and under map f जन छो map which matches x with y. ठीक है so we write y is equal to f of x, y is equal to f of x. ठीक है ऐसे च वुशन क्या ये function f of x छा differentiable at a particular point say a is any point within its domain. ऐसे च वुशन domain के यह point which happens to be a here at पे छा differentiable किन ठीक है then the function will be said to be differentiable at this particular point a if we have limit h tends to 0, f of a plus h minus f of a divided by h. ठीक है so we say or we denote this by f dash of a, or also it is read as f prime of a. ठीक है, f dash of a or f prime of a, f dash of a or f prime of a. So we say the function f of x is differentiable at a point x is equal to a if limit h tends to 0 f of a plus h minus f of a divided by h. ठीक है, so limit h tends to 0 f of a plus h minus f of a divided by h. ठीक है, so what actually we do, गोडनेथ इस function is small increment current. ठीक है, so we take the function of a, f of a means f of x, so we have function f of x. So f of x is much kya, f of x is much x is replaced by a, x is replaced by a, so it will be f of a, so it will be f of a. You see h, a is small increment current h, ठीक है, while h is greater than 0, which is a small positive number, small positive number. ठीक है, so it is on the similar line as you see h is a small increment in x. ठीक है, h is a small increment in x. So अगर इस यह result वुचो, यह result इस physics में इस पर कर define. So we define this as limit del x tends to 0 f of x plus del x, f of x plus del x minus f of a अगर इसने मोया था ना x plus del x plus f of x divided by del x ठीक है, where you see h is the synonym for del x. ठीक है, del x means small increment in x and h here means a small positive number. ठीक है, so small positive number also means a small increment in x. ठीक है, so you see result here. So this is the differentiability of a function at a particular point. So we say f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h. ठीक है, so we say function fx is differentiable at a point x is equal to a when f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h, provided the limit in the right hand side. You see limit this has to exist finitely. ठीक है, exist finitely मतलब ये गैस आसना finite real number. ठीक है, you see limit compute करने पर उस value है that should be a finite real number. समझ आया वहाँ? ठीक है, लिखिए definition of पहले write down. This is the derivative of a function at a single point. ठीक है, so f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h. ठीक है, so इस पर continuity मज़ बनिया continuity at a single point and continuity throughout the interval. Continuity at a single point and continuity throughout the interval. ठीक है, so as बनिया a function is said to be continuous when it is continuous for every point within its interval. ठीक है, so on a similar note अगर इस वनो a function is said to be differentiable. किम साथ आज differentiable when it is differentiable for every point within its interval. ठीक है, when it is differentiable for every point within its interval. ठीक है, so अतामत नियावच a particular point a. ठीक है, so we can निमो इसका general point से arbitrary point x निमो इसका थे arbitrary real number within its domain. Then we say f dash of x is equal to, ठीक है, so it will be f dash of x is equal to, it will be limit h tends to 0 f of x plus h minus f of x divided by h. ठीक है, so f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. ठीक है, now what is the difference between this thing and this thing? Can you differentiate? या तो भी या दरमियान क्या है difference? शाबाश नज़ारत what is difference between this and this? यहाँ पे पर्टिकुलर पॉइंट है यदन वुचान डिफरेंशिएबिलिटी एट ए पर्टिकुलर पॉइंट ये क्या वुचे डिफरेंशिएबिलिटी थ्रू आउट इट इज डोमेन. ठीक है, सो x is the arbitrary point within its domain, so x represents every point. So इस वनो तेल ये function is differentiable throughout its domain when it is differentiable for every point. ठीक है, so this x here represents that very every point. So f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. ठीक है, you see definition, so this is also called the definition of the derivative or it is also called a first derivative principle. first derivative principle, first derivative principle, first derivative principle, or it is also called a first derivative test, first derivative principle or first derivative test. ठीक है, यथे छे इस वना, it is also called ab initio method, ab initio method. ठीक है, so it is also called ab initio method. ठीक है, so this is first derivative test or first derivative principle, and it is also called the ab initio method. ठीक है, so ab initio method. Now yith pades which continuity man, so agar is a particular point A is, ठीक है, so at that point agar is graphs mas bas discontinuity, ठीक है, say if that point A was this, it was that point yatan discontinuity hek ٲسِتھ, ठीक है, til kya is that point is पे karan, we were computing the left hand limit and right hand limit, ठीक है, so is one the function will be continuous if the left hand limit at that very point coincides with the right hand limit, and that also coincides with the value of the function at that point. ठीक है, तम साथ is one function is continuous. ठीक है, so इथे पर छी ये हेको we can also find the left hand derivative and right hand derivative. ठीक है, so left hand derivative and right hand derivative. Suppose A is so point where the graph is supposed to have breaks. ठीक है, at that point as suppose x is equal to A, as A is पर करो left hand derivative and right hand derivative calculate. ठीक है, then left hand derivative is we denote left hand derivative by L f dash of A. ठीक है, L f dash of A means left hand derivative at A. ठीक है, left hand derivative at A. ठीक है, so this will be left hand derivative. So that is given by which is left hand derivative im साथ calculate is करा, we were putting x is equal to A minus h, and when we were computing the right hand limit we were taking x is equal to A plus h. ठीक है, so x is equal to A minus h and x is equal to A plus h. So exactly is similar line in pat heat kara calculate. So we compute limit h tends to 0 f of, when it is left hand derivative, so we put f of A minus h, f of A minus h, f of A plus h, exactly your definition. ठीक है, मगर A बदल क्या, since we are computing the left hand limit, so we'll write here A minus h. ठीक है, minus f of A. ठीक है, मगर बुन कन चीज लिखा minus h. ठीक है, so here we write minus h. So left hand derivative at f of at A, left hand derivative of the function at A is equal to limit h tends to 0 f of A minus h minus f of A divided by minus h. ठीक है, and right hand derivative is denoted by R into f dash of A, R into f dash of A, यानी right hand derivative at f of A. So which is written as limit h tends to 0 f of A plus h, f of A plus h minus f of A divided by plus h, divided by plus h. ठीक है, so simply one is still right hand use limit चासन right hand derivative, that is exactly this one. ठीक है, यहाँ मंचन कहाँ change, मगर इम साथ इस left hand derivative से compute करें, इम साथ क्या चीज़ लिखा A minus h बुनकन minus h. ठीक है, and obviously the limit at that point, the derivative at this point x is equal to A will exist. So derivative at x is equal to A will exist when the left hand derivative at x is equal to A will be equal to the right hand derivative at x is equal to A. ठीक है, so that means L f dash of A is equal to R f dash of A. ठीक है, so the left hand derivative at x is equal to A has to be equal to the right hand derivative at x is equal to A. समझ आया वहाँ, ठीक है, so लिखिए, write down. Now f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. ठीक है, we know we can use y is equal to f of x. ठीक है, y is equal to f of x when we define the relation between the or if we define the association between the domain and the codomain. ठीक है, so we match y with x along the rule f or with the help rule f. So y is equal to f of x, y is equal to f of x. Now this y is equal to f of x अगर इस ज़्यादा वुचो, ठीक है, y is equal to f of x. So अगर इस इमेक derivative छो, ठीक है, y is equal to f of x, इमेक derivative है को इस denote करें by dy by dx. ठीक है, y derivative that will be denoted by dy by dx. That means use dy by dx use this is the symbol which denotes the differentiation. ठीक है, so dy by dx is called the differential operator. d by dx this is called the differential operator. ठीक है, so differential operator अगर इस y पे करो apply then we can denote this as by d by dx of y. ठीक है, but we combine this as dy by dx, dy by dx. ठीक है, so dy by dx we can also denote this as dy by dx is symbol it was first used by Leibniz. ठीक है, so as I told you it was first used by Leibniz. ठीक है, and interesting thing about these symbols is कि जो mathematical giants, different mathematical giants, they used their own symbols. ठीक है, their own differential symbols. So as an example you say dy by dx it was used by Leibniz. ठीक है, use Newton used this notation as y dash. ठीक है, y से अगर differentiation करो then it will be y dash or y prime, y dash or y prime. So this y dash or y prime this is called a Newton's notation. And in fact it was used by Newton's. ठीक है, so y dash is the Newton's notation, Newton's notation. So ब्याक notation, so it was f of x. जैसे कि यहाँ पे हमने define किया f of x याद को ना f dash of x, f prime of x. So f of x which अगर इस differentiation करो that will be denoted by f of x, and this notation is due to, so this was used by Leibniz, this by Newton, and this was used by Lagrange, Joseph Louis Lagrange. ठीक है, so this is called the f dash of x, this is called the Lagrange's notation. And ब्याक notation ची use गसन इत पढ़न d, this stands for the differential operator ना, इत पढ़ ये d by dx, so this is again equal to d. ठीक है, so this is the differential operator. So you see differential operator d, so अगर इस y size differentiation करें with respect to x then this is denoted as dy. ठीक है, यादन ची small suffix x था ना. ठीक है, so this means the differentiation of y with respect to x, and this notation was used by Euler. So this is called the Euler notation. ठीक है, so we have different notations. प्रथ का notation is used करन. ठीक है, and we are using them simultaneously. Once इशेकन at the same time एक book में या एक reference में जासन सारी notation आमस use करन. ठीक है, without a specific mention of the symbols we use or notations we use. So dy by dx ये notation का सन Leibniz. So this is Leibniz notation, and y dash or y prime this is Newton's notation, and f dash of x this is Lagrange, and dy with respect to x, so dy. ठीक है, so x here represents the independent variable, this is due to Euler. ठीक है, so ब्याक notation ची use Euler which is a famous notation by Euler. कुछ the integral symbol. ठीक है, integral symbol you see it was also used by Euler. ठीक है, so infinity that is also the symbol given by the Euler. ठीक है, so these were the some of the prominent symbols which were used by Euler. ठीक है, so चाहे आप dy by dx या y dash या f dash of x or dy. ठीक है, so they all will mean the derivative of the function y with respect to x. But you see notation ये देखिए dy by dx you see notation छे. ठीक है, I सोच के you see dy by dx this is the operator. ठीक है, dy by dx this is the operator which we apply on a function. ठीक है, इसे कोई इस पर लिखिए d by dx of y. ठीक है, और we can combine this to give dy by dx. ठीक है, मगर use your notation ची dy by dx it was made as flexible as possible by the Leibniz. ठीक है, Leibniz बनो ये notation is a flexible कि इसे कोई dy by dx we can treat them as constants. ठीक है, इसे को since dy by dx use d by dx use ना इसे एक particular notation, but this notation was made flexible by Leibniz कि इसे को dy by dx इसे कोई separate करिए. we can write dy and we can write dx, even dy to be dx है को transpose करिए like we do with the variables. ठीक है. So this symbol d by dx, so this was made as flexible as possible so that we can treat them as constants. If it is constant hekan x side पे big side transpose करियो. So इसी notation च, so this was made flexible by Leibniz. ठीक है. So इस वुचो ये d by dx is transposed करन by in differential equations. Differential equations में वुचो it. So we can deal with these d by dx as we are dealing with a variable. इसे कोई x side पे big side is transposed करियो. ठीक है. So this notation d by dx, this was given by Leibniz. ठीक है. Continuity to be differentiability which is one. Now do you find any link between continuity and differentiability? Do you find any link between continuity and differentiability?
Yes, sir.
A function agar differentiable is, will that function be continuous?
Yes, sir.
कौन सी? Two results are there. Is a continuous function differentiable or a differentiable function continuous? अच्छा, the result one बताया. Number first, एजाज वन इमेक आंसर. Is differentiable function continuous? Is every differentiable function continuous? क्या प्रत का differentiable function आशा continuous? है कैसे? Is every continuous function differentiable? अच्छा differentiability इस पर continuity वुचना. Continuity means कि as we should have a continuous graph or that won't have any breaks. ठीक है. तथ मज गछ कुन जाय गछन सु graph break गछन के. ठीक है. कुन जाय गछन सु split गछन into two parts के. So differentiability of a function, graphically differentiability of a function means कि इस गसो हेकन प्रत एकस पॉइंटस पेट आस टेंजेंट त्रयित. इस गसो हेकन प्रत एकस पॉइंटस पेट टेंजेंट त्रयित, and at that very point we should be able to find the slope of the tangent. ठीक है. So which means graphically the differentiability of a function means, या geometrically what do we mean by differentiability of a function? So differentiability of a function means, suppose I zanchi kanti function zanchi, ठीक है, kanti function. So A is any point within it is domain, A is any point within it is domain, ठीक है. is zanchi point x is equal to A, x is equal to A, ठीक है. Then if we write dy by dx, so differentiation of the function or derivative of the function at a particular point x is equal to A, ठीक है. So dy by dx at x is equal to A, that is denoted by dy by dx at x is equal to A. या है कोई इस पर simultaneously we can write f dash of A, ठीक है. So f dash of A which will be equal to dy by dx at x is equal to A, at x is equal to A. So अगर इस A पेट से अमुक डेरिवेटिव वुचान, then geometrically that means कि इस point A on which lies on the function f of x, at point इस पेट हेकवा इस tangent त्रे, ठीक है. at point इस पेट हेकवा इस tangent त्रे, so it is like this, ठीक है. ये tangent जंच इन tangent slope क्या है, ठीक है. So geometrically the derivative of a function at a particular point means slope of the tangent, ठीक है. So dy by dx at x is equal to A means slope of tangent, ठीक है. So we can say geometrically the derivative of a function at a particular point means slope of the tangent at that point, ठीक है. Now which is one कि अगर differentiable function is every differentiable function continuous or every continuous function differentiable?
Every continuous function is differentiable.
So which means does differentiability imply continuity? Does differentiability imply continuity or continuity imply differentiability? Naila one. Continuity imply differentiability. One sir. Shabash. Differentiability implies continuity or continuity implies differentiability. ठीक है. कुछ statement जो मोमस true. Differentiability implies continuity or continuity implies differentiability. First or second? First or second? Second. Is every differentiable function continuous or every continuous function differentiable? Every continuous function is differentiable.
Yes, sir.
शाबाश. कुछ आ स्टेटमेंट से एग्री करा. is every यानी तुझ ना दोयम statement ची true ठीक है दोयम statement ची true कहीं every continuous function is not differentiable that means continuity does not imply differentiability continuity does not imply differentiability ठीक है but differentiability does imply continuity what does this mean every differentiable function is continuous ठीक है every differentiable function is continuous मगर इमुक converse आशना always true कहीं that means every continuous function is not always differentiable ठीक है so differentiability implies continuity that means every differentiable function is continuous function every differentiable function is continuous function while every continuous function is not differentiable function ठीक है so आठ direction में लिखिए तो theorem लिखिए write down every number से लिखने की ज़रूरत की है ना so every differentiable function every differentiable function is continuous every differentiable function is continuous so every differentiable function is continuous ठीक है यह कोई to be more specific we can write if a function is differentiable at a particular point then it is continuous at that point ठीक है so alternate statement लिखे में बासा ना which को alternate statement ते लिखे था we can say कि use the function differentiabilize at a single point that will be continuous at that very point ठीक है so we can write which को ब्याक statement ते लिखे था so we can write if fx is continuous if fx is differentiable if fx is differentiable so the alternate statement will go like this so if fx is differentiable at x is equal to a then it is also continuous at x is equal to a then it is also continuous at x is equal to a ठीक है so if fx is differentiable at x is equal to a then it is also continuous at x is equal to a that means the differentiable function at x is equal to a means it is continuous as well at that very point ठीक है so if we have to prove this so assume and the function is differentiable ठीक है given that the function is differentiable so given fx is differentiable at x is equal to a fx is differentiable at x is equal to a when do we say fx is differentiable at x is equal to a shabash danish when do we say the function is differentiable at x is equal to a when f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h ठीक है so given f of x is differentiable at x is equal to a so therefore f dash of a ठीक है f dash of a is equal to it will be limit h tends to 0 f of a plus h minus f of a divided by h ठीक है so f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h ठीक है so यादन करें simply the use of the definition ठीक है the definition of differentiability so it is given fx is differentiable at x is equal to a that means f dash of a इसका बराबर limit h tends to 0 f of a plus h minus f of a divided by h ठीक है now if we put x is equal to a plus h यहाँ देखिए सभी put x is equal to a plus h ठीक है we put x is equal to a plus h so x is equal to a plus h इम साथ change of limit को ठीक है a plus h so इम साथ x is equal to a plus h यानी change of variable then we'll change limits as well ठीक है so put x is equal to a plus h so when h tends to 0 where will x tend to h tends to 0 so x will tend to a ठीक है so x will tend to a h tends to 0, so x tends to a, x tends to a. So therefore we have f dash of a is equal to, f dash of a is equal to, so this will be limit h tends to a go change kath mans, x tends to a, x tends to a, so f of a plus h is replaced by x, so this will be f of x minus f of a divided by h से करो replace it किम से, so h, अब h का वैल्यू यहाँ से आप लीजिए, what will be value of h, so h will be x minus a, ठीक है, so h is equal to x minus a, so this will be x minus a, ठीक है, so this is, so f dash of a is equal to limit x tends to a f of x minus f of a divided by x minus a, ठीक है. You see equation ch, if we name this equation as equation star, ठीक है, as an thought equation star now, ठीक है. Now if we take now f of x minus f of a, ये जन करो इस compute f of x minus f of a, ठीक है, f of x minus f of a. Now f of x minus f of a, can we write f of x minus f of a as f of x minus f of a divided by x minus a? Yes sir. है कोई लिखे किस पर x minus a go ना अला, so क्या करो, we'll cancel out that x minus a by multiplying with x minus a. So f of x minus f of a can be alternatively written as f of x minus f of a divided by x minus a into x minus a, ठीक है, x minus a will cancel out, so it will be again f of x minus f of a, ठीक है. So वहाँ अगर यह यू सी वैल्यू से या जन निमो limits both sides, ठीक है, so taking limits both sides, so it will be limit x tends to a f of x minus f of a, f of x minus f of a is equal to, या side से निमो ना limit, so it will be limit x tends to a f of x minus f of a, f of x minus f of a divided by x minus a, ठीक है. Since we know limit of product is product of limits, यानी यह portion गैस अलग limit distribute याद गैस अलग, ठीक है, limit of product is product of limit, so it will be limit x tends to a x minus a, ठीक है, limit x tends to a x minus a. Now limit x tends to a f of x minus f of a divided by x minus a, what is this equal to, by equation star limit x tends to a f of x minus f of a divided by x minus a का बराबर छ f dash of a, so this will be f dash of a, ठीक है, f dash of a into, since this is a polynomial function limit x tends to x minus a, है polynomial function, we can directly use the limits here, ठीक है, because ये बनने undefined कहें, so it will be a इम साथ x दिमो value 0, so it will be a minus a will be 0, so this will be into 0. F dash of a is, f dash of a means it will be a constant because we are differentiating a, it will be f dash of a, so into 0, so what will be the value 0, ठीक है, ये का बराबर 0 बराबर, so which means यादन कर complete, yeah. So this is limit x tends to a f of x minus f of a is equal to 0, ठीक है, since we know limit of difference is difference of limits, ठीक है, limit of difference is difference of limit, that means f of x is अलग limit, f of a is अलग limit, so it will be limit x approaches to a f of x minus limit x approaches to a f of a is equal to 0, ठीक है, but f of x function f of a will be a constant, f of a will be a constant, ठीक है, function of constant, it will be a constant, so we know limit of the constant is the constant itself, limit of the constant is the constant itself, so that means it will be limit x tends to a f of x, ठीक है, minus f of a, ठीक है, minus f of a is equal to 0, ठीक है, लिमिट का लिमिट यथ लिमिट ठीक है, जीमिक लिमिट क्या, लिमिट x टेंड्स टू f of a is f of a. अब इसे यहाँ शिफ्ट कीजिए राइट हैंड साइड में, सो इट मीन्स लिमिट x टेंड्स टू a f of x is equal to f of a, ठीक है, एंड व्हाट इज दिस, limit x tends to f of x is equal to f of a. This is in fact the definition of the continuous function, ठीक है, यानी limit x tends to f of x is equal to f of a. That means कि अगर आप function f of x differentiable at x is equal to a, this means limit x tends to f of x is equal to f of a means f of x is continuous at x is equal to a. F of x is continuous at x is equal to a. ठीक है? So that means every differentiable function is continuous function. So every differentiable function is continuous function. समझ आया वहाँ? ठीक है? Repeat मच करने ज़रूरत? ठीक है? लिखिए जल्दी फिर. So differentiability of a function implies continuity. ठीक है? So differentiability implies continuity. So differentiability implies continuity. So differentiability implies continuity, but continuity does not imply differentiability. ठीक है? So but continuity does not imply differentiability. Continuity does not imply differentiability. Continuity does not imply differentiability. That means a continuous function is not necessarily differentiable function. ठीक है? So remark एक ऐड कीजिए. Every continuous function is not differentiable. 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 ठीक है? प्रत का continuous function छन differentiable आसान की. ठीक है? So as an example, we know modulus function. Modulus function is graph क्या है आसान? It is V-shaped graph. ठीक है? So V-shaped graph. So which touches at the origin. ठीक है? So f of x is equal to mod of x. F of x is equal to mod of x. F of x is equal to mod of x. ठीक है? In fact we know अगर यह is mod of x minus a, ठीक है? Why does it land on the x axis? At point a. ठीक है? इसने टच करा कतन x axis at point a. ठीक है? So a may be positive or it may be negative. ठीक है? If we have suppose x minus 5, mod of x minus 5, ये कतन से टच करा x axis at point x is equal to 5. ठीक है? At point x is equal to 5. So at point x is equal to 5. ठीक है? इधर present x is x plus 5. x plus 5 ये कदम का टच x axis at point x is equal to minus 5. At point x is equal to minus 5. ठीक है? यस ये मॉडुलस फंक्शन छ यथ पॉइंटस पे टच करान x axis तथ पॉइंटस पे ये डिफरेंशिएबल आसान कहीं. ठीक है? So it is not differentiable at that point where it touches the x axis. ठीक है? So f of x is equal to mod x. Why does it touch the x axis? x is equal to 0. ठीक है? x is equal to 0. So you see function ch it is not differentiable at x is equal to 0. So the modulus function f of x is equal to mod of x is not differentiable at x is equal to 0. ठीक है? At x is equal to 0. In fact f of x is equal to mod x can also be written as mod of x minus 0. ठीक है? Mod of x minus 0. So this function is not differentiable at x is equal to 0. ठीक है? लिखिए the function f of x is equal to mod x. The function f of x is equal to mod x is not differentiable at x is equal to 0. The function f of x is equal to mod x is not differentiable at x is equal to 0. ठीक है? Where f of x is equal to mod x is not differentiable at x is equal to 0. ठीक है? अच्छे already वुचमुत युस function च f of x is equal to mod x. This is continuous throughout its domain. ठीक है? Domain किस हर एक point खतर च continuous. ठीक है? So it is continuous but not differentiable at x is equal to 0. x is equal to 0 especially differentiable कहीं. ठीक है? वजन ऐसे check करूँ. Why is it not differentiable at x is equal to 0? ठीक है? Then we have to use here the left hand derivative and right hand derivative. ठीक है? And we have to compute the left hand derivative at x is equal to 0 and right hand derivative at x is equal to 0. ठीक है? So we'll check at x is equal to 0. At x is equal to 0. ठीक है? At x is equal to 0. I switch odamat the left hand derivative at x is equal to a. What is that equal to L? f dash of a, L f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h. This is minus h, yatan minus h, f of a minus h. So left hand derivative which is now a f of a minus h minus f of a divided by minus h, and right hand derivative which is now r f dash of a which is limit h tends to 0 f of a plus h minus f of a divided by h. ठीक है, ये क्या छो a is क्या छो value, a is equal to 0. ठीक है, so that means we have to check the left hand derivative of the function which is the modulus function at x is equal to 0. ठीक है, अगर इस left hand derivative करो compute, so it will be L f dash of a की जगह 0, so L f dash of 0 which means the left hand derivative of the function at x is equal to 0. और function कुछ है था modulus function f of x is equal to mod of x. So using this definition, so there will be limit h tends to 0, so f of a means, so it will be 0 minus h minus f of 0 divided by minus h. Now what is f of x equal to? F of x का बराबर छो mod of x. F of x is equal to mod of x. So it will be limit h tends to 0. So f of x is equal to mod of x. What will be f of 0 minus h? So क्या बराबर ही mod of 0 minus h. So it will be mod of 0 minus h minus f of 0. F of 0 is mod of 0 divided by minus h. So it will be limit h tends to 0. So mod of so this will be mod of minus h minus mod of 0, that is 0 divided by minus h. So which is limit h tends to 0, mod of minus h is h divided by minus h. So h and h will cancel out, so it will be minus 1. So minus 1 of limit, so go minus 1. Limit of the constant is the constant itself. So left hand limit का बराबर minus 1. Now right hand limit, so it will be r f dash of 0. ठीक है, r f dash of 0 which will be limit h tends to 0 f of 0 plus h minus f of 0 divided by h. So it will be again limit h tends to 0 f of 0 plus h का बराबर ही mod of 0 plus h, very good, minus mod of 0 divided by h which will be limit h tends to 0. ठीक है, so it will be h divided by h which is equal to 1. Left hand derivative is minus 1, right hand derivative is 1. That means left hand derivative and right hand derivatives बराबर हैं, which means the function is non-differentiable at x is equal to 0. ठीक है, but the function is continuous and not differentiable at x is equal to 0. That means use the continuous function ch lazim chin kin ki ya is kya differentiable function. So every continuous function is not differentiable, and so as an example f of x is equal to mod x, it is not differentiable at x is equal to 0. ठीक है, समझ आया? रिपीट मश करो, लिखिए.